Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3301. Subject name Data Structures. Unit 5 Searching, Sorting and Hashing Techniques. The topic to be learned in this presentation is hashing. The types of hashing, that is one separate chaining and second one is open addressing. First, hashing. Hash table is a data structure which stores data in an associative manner. In a hash table, data is stored in an array format where each data value has its own unique index value. Access of data becomes very fast if we know the index of the desired data. Thus, it becomes a data structure in which insertion and search operations are very fast irrespective of the size of the data. Hash table uses an array as a storage medium and uses hash technique to generate an index where an element is to be inserted or is to be located from. Hash function h of x can be defined as h of x is equal to key mod size of the table. The two types of hashing techniques are separate chaining and open addressing. First, separate chaining. The idea behind separate chaining is to implement the array as a linked list called a chain. If two different elements have the same hash value, then we store both the elements in the same linked list one after the other. Example, let us consider a simple hash function as key mod 7 and a sequence of keys as 50, 700, 76, 85, 92, 73, 101. H of x can be calculated using the formula h of x is equal to key mod 77. Key mod 7. Initially, it is an empty table, stores from 0 to location starts from 0 to 6. The first element is 50, which is to be inserted. The h of x for 50 is 1. So it has to be inserted at the location 1. Second element is 700. The h of x for 700 is 0. So it is inserted at the location 0. Next value is 76. The h of x for 76 is 6. So it is inserted at the position 6. Next element is 85. H of x for 85 is 1. Now when we try to insert 85 at the position 1, we came to know that collision occurs and we have to make a chain here. It is shown in the figure. Next element is 92 and when we and h of x for 92 is 1. Again collision occurs when we try to enter the 92 at the position 1. So again we have to make a chain. This is shown in the figure. And the next value is 73 and h of x for 73 is 3. So it is inserted in the position location 3. And last value is 101. The h of x for 101 is 3. Again when we try to insert 101 at the position 3, we will found a collision. So again chain has to be made. It is shown in the figure. This is called separate chaining method. Next is open addressing. In this technique, all elements are stored in the hash table itself. So at any point, the size of the table must be greater than or equal to the total number of keys. There are three kinds of open addressing. They are linear probing, quadratic probing, and double hashing. First, linear probing. In this method, when collision occurs, the key has to be inserted into the next free slot. Let us consider a sequence of keys as 50, 700, 76, 85, 92, 73 and 101 and h of x is equal to key mod 7. So first initially the table is empty and the location is from 0 to 6. First value is 50. It is inserted at the position 1. Second value is 776. The hatch of x for 700 is 0. So it is inserted at the position 0. For 76, hatch of x is 6. So it is inserted at the position 6. Next 85, the hatch of x for 85 is 1. Now the collision occurs. So insert 85 at the next free slot. And next value is 92. And again 9 for 92, the hatch of x is 1. So collision occurs with 50. So again insert 92 in the next free slot. And next value is 73. For 73, hatch of x is 3 and it already 3 is filled. So insert it to the next position. And next value is 101. Again hatch of x for 101 is 3. Again collision occurs. So insert the value in the next free slot. This is called as linear probing. And next, quadratic probing. This method is also known as the mid-square method. In this method, we look for the I-squared slot in the ith iteration. We always start from the original hash location. If only the location is occupied, then we check the other slots. Let hash of x be the slot index computed using hash function. If slot hatch of x percentage yes is full, then we try hatch of x plus 1 star 1 percentage yes. If hatch of x plus 1 star 1 percentage is also full, then we try hatch of x plus 2 star 2 percentage yes. If hatch of x plus 2 star 2 percentage is also full, then we try hatch of x plus 3 star 3 percentage yes. Example, let us consider a table size equal to 7. Hash function h of x is equal to x mod 7 and collision resolution strategy to be f of I is equal to I squared. Insert the elements 22, 30 and 50. Step 1. Create a table of size 7. Insert step 2. Insert 22 and 30. Hash of 22 is equal to 1. Since the cell at index 1 is empty, we can easily insert 22 at slot 1. H of 30 is equal to 2. Since the cell at index 2 is empty, we can easily insert 30 at slot 2. Inserting 50, h of 50 is equal to 1. In our hash table, slot 1 is already occupied. So, we will search for slot 1 plus 1 squared, that is 1 plus 1 is equal to 2. Again, slot 2 is found occupied. So, we will search for cell 1 plus 2 squared, that is 1 plus 4 is equal to 5. Now, cell 5 is not occupied. So, we will place 50 in slot 5. Third one, double hashing. In this technique, increments for the probing sequence are computed by using another hash function. We use another hash function hash 2 of x and look for the I star hash 2 of x slot in the ith rotation. Let hash of x be the slot index computed using hash function. If slot h of x percentage yes is full, then we try h of x plus 1 star hash of 2x percentage yes. If h of x plus 1 star h of 2 of x percentage yes is also full, then we try h of x plus 2 star hash 2 of x mod s. If h of x plus 2 star hash 2 of x percentage s is also full, then we try h of x plus 3 star hash 2 of x percentage s. Example, insert the keys 27, 43, 692, 72 into the hash table of size 7, where first hash function is h1 of k is equal to k mod 7 and second hash function is h2 of k is equal to 1 plus k mod 5. Step 1. Insert 27. H of 27 is equal to 6. So location 6 is empty, so insert 27 into slot 6. Step 2. Insert 43. H of x for 43 is 1. Location 1 is empty, so insert 43 into slot 1. Insert 692. H of x for 692 is 6, but location 6 is already being occupied and this is a collision. So we need to resolve this collision using double hashing. So h new is equal to h1 of 692 plus I star h2 of 692 mod 7. So finally we get the h of x as 2. Now as 2 is an empty slot, so we can insert 692 in the slot 2. Insert 72. So h of x for 72 is 2, but location 2 is already occupied and this is a collision. So we need to resolve this collision using double hashing. So we have to find again h new using the same formula what we used already to insert 692. So now the new hash value is 5. Now as 5 is an empty slot, so we can insert 72 into the slot 5. Thank you.